In previous lessons, we discussed that to be congruent, the figure would have to have all the corresponding sides would need to be congruent and all the corresponding angles would need to be congruent. Well, what we're going to see today is that it actually doesn't take all of the pieces. It doesn't take 6 pieces for a triangle, 3 sets of congruent sides and 3 sets of congruent angles. It actually can be done with fewer pieces. It just has to be the right pieces. And so one of them, we're going to talk about 3 of them today. So one of them is if I have 3 sets of congruent sides. It's called the side-side-side theorem. And it says that if 3 sides of one triangle are congruent to 3 corresponding sides of the second triangle, then the 2 triangles must be congruent. So I don't even have to know anything about the angles, because what happens is the angles kind of take care of themselves. So imagine if you have 2 boards that are the length of AB and 2 boards that are the length of AC, and 2 boards that are the length of BC, you would be able to build 2 triangles that are exactly the same size. If I gave 2 different teams 1 board of each length and they were the same, you would both create the same size triangle. So we can look at these triangles and decide whether they're congruent. If so, then the reason right now would be side, 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 and we can complete the congruent statement. So I notice then in this triangle, and I like to mark one triangle up so that I can see what I have. So I have DG is congruent to HK. I have that FD is congruent to JH. And I have that FG is congruent to JK. And since I have 3 sides of one triangle congruent to 3 sides of the other triangle, I can say that yes, these triangles are congruent. They're congruent because of the side-side-side theorem. Then FDG is congruent to the order of this matters. So you want to match up how they're marked. So F is up here between the sides that are marked with 2 marks and 3 marks, and it matches up with J. So FDG matches up with J. D is right here between the 1 mark and the 2 marks. So then H goes with D, and then G goes with K. So J goes with F, D goes with H, and G goes with K. Okay, so look at these 2 triangles. What I notice that these 2 triangles share this side AC. So AC is congruent to AC in both triangles. And then I've got a 7 congruent to a 7. So I've got these 2 sides are congruent to each other. But what I noticed is that AB is not congruent to CD. So the answer then would be no, because it takes 3 sides. Well, if they're not congruent, then there is no congruent statement. You can't write it. If they're not congruent, there's no way to say that they are. And then this last one, sometimes we don't know everything. Like we did on number 1, everything was already pre-marked for us. So on number 3, we have to look and go, okay, was there any additional information that we know? Well, I know that AD is congruent to DC. I know that AB is congruent to CB, but the other thing that I know, and I can look at it, is if you recall, these 2 triangles, I have this triangle here, ADB, and I have this triangle here, CBD. Those 2 triangles share this side BD, and BD is equal to BD because of that reflexive property. So I have 3 sides of one triangle congruent to the same 3 sides of the red triangle. So that means, yes, these 2 triangles must be the same size because of the side-side-side theorem. And A, B, D match them up. So A is in that lower left-hand corner. It matches up with C. And then B is up here at the top. B will match B. And then D will match D. So that is how we use the side-side-side theorem to prove that triangles are congruent. There's another option that we have. If 2 angles and the included, or excuse me, if 2 sides and the included angle are congruent to 2 sides in the included angle of a second triangle, then the triangles have to be the same size. Now, this is really important. It's included. That's the most important part. 2 sides and the included angle. So in general, the included angle would look like this. So I have a side of a triangle and a side of a triangle. The included angle would be right here, kind of like an ice cream cone holding the ice cream. So that would be included. So this has what it looks like to be included. And then this is what it would look like to be not included. The angle would be up here. So imagine, I mean, we kind of have, if we have this triangle, right, with this third side, and I've got these two angles, I've got these two sides. I have this side and this side labeled, and this side and this side labeled. Okay, this, the first one is included. This angle is not included. It's not between those two yellow sides. So that's what it means to be included. So if you notice right here, I have this side, BC is congruent to XZ. I have AC is congruent to YZ. And then I have this angle right here nestled down in between them at angle C, and it is between. And both of those have that angle in between those two sides. Okay, so short for this is side, angle, side. Now, just like the angle is right in between those two sides, the letter A is in between those two S's. That's how you can keep straight. So side, angle, side. Now, what happens though if you end up with one where it's not included? Well, when it's not included, like this one right here, so see I have this side, and then this angle's kind of hanging off the end. It's not between the two sides that are marked. What can happen is this one edge right here, this side right here can be swung out so that it creates a second triangle. It doesn't have, because that angle's not holding it in place. See, this angle right up here, this one is holding those two sides in place so that they can't move. It's anchored, right? We've got it, it's like anchored down right here. We put a pin in it and it can't move. Well, if the pin is over here, there's nothing to hold this side down, and so it can swing back and forth. So since it can swing back and forth, it can open up and create this triangle right here. So SSA does not prove that triangles are congruent. You cannot use SSA to prove that triangles are congruent. However, there is one alternative. If the triangle is a right triangle, okay, if it is a right triangle and I have the hypotenuse and one leg, okay, so if it looks like these triangles here, it won't work. But what if it looks like this? What if what I have marked is the hypotenuse and a leg? Well, that is a side, and the angle is off to the end, and it's not being anchored. However, because it's a right triangle, that right angle right there, it anchors these sides down. And so because it anchors those sides down, we can't use SSA. We never can use SSA, but what I can use is I can use what's called HL, and HL means hypotenuse leg. So whenever you have a situation and it looks like it could possibly be SSA, what you want to look for is it a right triangle? Because if it's a right triangle, then you have a hypotenuse and a leg, and you can say that the triangles are congruent. Because the right triangle, the right angle anchors everything down and holds it in place. Okay, so that's the only time that when you're given two sides with a non-included angle that it's even possible for the triangles to be congruent. So let's look at a mixture of these triangles and see if we can prove that they're congruent. Remember, we're looking for side, 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 angle, side, or HL. And if it's not one of those, then the answer is no. So I look at these two triangles here. I have triangle ADC. I have this green triangle. And then I have this yellow triangle right here, ABC. And I look and I see what I have. Well, I notice that I have a side congruent to a side. I have another side congruent to a side. And then I don't have anything about the angles, but what I do see is that I have two triangles back to back, which means that because of the reflexive property, that side is also congruent. So I have three sides of the yellow triangle congruent to three sides of the green triangle, which means yes, these triangles are congruent by the side, side, side theorem. And that ABC is congruent to C, D, A. So notice how they're marked. So A starts here. It's between the one that's marked with 1 mark and 3 marks. And so I would start the same place up here. C is between the 1 mark and the 3 marks. And then D goes out here between 1 and 2. B is over here between 1 and 2. And then C ends between 2 and 3. And then A ends between 2 and 3. Okay, so let's look at this next one. So let's look at what we have. I have an angle, and then I have a side, and then I have another side because AC belongs to both triangles. Now look at where that angle is, right? If I have these two sides, maybe it'd be helpful to see the sides as two different colors. So I've got my sides, and then I've got this angle hanging out here over on the end. It is not nestled down in there between those two sides. There is nothing anchoring this third side down. I know that those are reflexive. AC is reflexive. So I have a side, and I have a side and an angle. Well, the angle is not in between. So my only option is it side angle side? And the answer is no. It's SSA, but remember that SSA never proves that triangles are congruent. And so the answer is no, because it's not a right triangle. So that's the next question is you need to say, okay, is it side, side, side? No. Is it side angle side? Look for the angle. If the angle is not in between the two sides, then you ask yourself, is it a right triangle? So let's look what we know about problem number 3. Problem number 3, notice this. You always are given information for a reason. So notice this. Okay, so here's what I've got. I've got two triangles that are that have parallel sides. Okay, so I have this yellow triangle here. I have this green triangle here. And I want to see what they've got. Well, I notice they're back to back. So instantly, I already know that AD, so I have a side congruent to a side. I have another side congruent to a side. I'm just marking them with an S so that I can keep up with my letters. Another side congruent to a side. And then I don't have anything else. Well, what I do know, though, is you've got to use all the information in the picture. I do know that these two are parallel. And so then if I use those two parallel lines with a transversal, what I have is that angle 2 is congruent to angle 4. Well, notice where that angle is. It's between those two sides. It's being held in, right? If I pin that down, it's going to hold those two sides in place. And so my angle is right there in between those two sides. So yes, these two triangles are congruent because of side angle side. And A, B, D, so you would look at your markings. So angle A to B, so we go A to B to D, and I want to match that, then I'm going to go D to C to A. So ABD is congruent to DCA. So let's look at this one. Always look at the things that you are marked and the things that aren't marked. So one of the things that is not marked is AC. Well, AC is congruent to AC because of the reflexive property. So here's what I have. I have a side, AB is congruent to AD. I have a side congruent to side, right? I have AC is congruent to AC because of the reflexive property. And then I have this angle right here. Now, that angle, though, is 90-degree angle. So notice, I have a side, and I have a non-included angle. So remember, SSA never proves triangles are congruent, but it's a right triangle. And since it's a right triangle, then I have to look and say, okay, do I have a hypotenuse and a leg? So it's a right triangle. This side is the hypotenuse, and I have one of the two legs. So yes, these two triangles are congruent, and they're congruent because of HL. If this had not been a right triangle, then the answer would have been no with the placement of those angles. So because they are congruent, DAC would be congruent to BAC. You want to match up your angles. So D and B match up, A matches with A, C matches with C. Now, if we look at 5, notice that we have an angle, we have a side congruent to a side. We have AB is congruent to BE. We have BD is congruent to BC. And then also, don't forget, it's not stated, but we know it. We know that ABD, the angle ABD, is congruent to angle EBC because they're vertical angles. So we know this also. So notice where that angle is. There's my side, there's my angle, there's my side. If I pin down that angle is going to hold those sides in place. So it is side, angle, side. So yes, the triangles are congruent because of side angle side. And ABD is congruent to EBC. Then lastly, we have this right triangle. Now, don't assume that every right triangle is going to be HL, okay? So that's something we've got to look for. So we've got this AC. Don't forget, notice the things that aren't marked. AC is congruent to AC. So AC of this yellow triangle is congruent to AC of this pink triangle. Okay, so AC is congruent to AC. BC is congruent to BC. Or BC is congruent to CD, and then this is the angle that I have, because if that one on the pink triangle is a right angle, then so is this one. That's a right angle. So now look what I have. So look at where everything is. So I have this side right here, and I have this side right here, and I have this angle here in the middle, right? Pin it down. It's going to lock it down. So this is congruent, but they're congruent by side angle side. Now notice, it can't be HL anyway because I don't have the hypotenuse. Okay, that's the hypotenuse and it's not labeled. So you can't use HL because it's not marked. Okay, and then ABC is congruent to ADC. So we have 3 ways so far. We don't need all 6 pieces of information. We just need 3 pieces in the right order. We need to have 3 sides of one triangle congruent to 3 sides of another triangle. We need to have 2 sides congruent with the included angle. Okay, so we need it to look like this. If we have this angle, we need it to look like this, not like this. Okay, actually, let me draw it as a triangle so it'll be like what you see, where we're talking about this side and this side and this angle, and not this side and this side and this angle. Okay, so that's the difference. If it is that side-side angle, which does not prove that triangles are congruent, if it is that, then you have to check. Okay, so if it's SSA, then you need to check, is it right? Is it a right triangle? Okay, so if no, then no, it's not a triangle. It's not a congruent triangles. If yes, is it HL? Do you have the hypotenuse in the leg? Then it would be yes. Okay, so if no, then it's not. And if yes, then it is. Okay, so far we have side, 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 angle, side, and